Hi everyone, in this lecture I am going to talk about spectroscopy. Spectroscopy is the study of interaction between electromagnetic radiation with matter. Electromagnetic radiation is something that has both electrical as well as magnetic field. The electromagnetic radiations are considered to have both wave as well as particle properties. So in case of wave property, the electromagnetic radiations have the capacity to reflect, refract, diffract as well as show interferences. So reflection is something if you pass the light radiation, that is electromagnetic radiation, through one medium, and when it falls on the reflective surface, the light radiation will be reflected back. That is called as reflection. And the refraction is something when the light radiation passes from one medium to another medium, and while it passes through the another medium, that is the second medium, it will change its direction and it will flow in different path. That is called as refraction. It is going to flow in the same direction, but its angle will vary. And the diffraction is something that happens when the light radiation is allowed to fall on a obstacle that has a narrow origin. And if the light radiation is allowed to pass on that narrow origin, what will happen is the light radiation will be diffracted on the other side. It will be spreading from the small origin. That is called as diffraction. And interferences is something when two or more radiations are flowing in one space, it will collide with each other and will undergo either constructive or destructive interference. So constructive interference means that the two light radiations will combine together to produce a longer one, and destructive interference means that two light radiations will combine together and get destroyed. That is called as destructive interference. So electromagnetic radiations are considered to have all these wave properties. And when it comes to particle properties, the electromagnetic radiations have energies. They have energies in the form of discrete packets. So that is why electromagnetic radiation is considered to have both wave as well as particle properties. Now, as per the definition I have said now about spectroscopy, these electromagnetic radiations will go and interact with the matter, that is atom or molecule. An atom is a single element, but whereas the molecule is the two or more atoms combined together. So what will happen is if we pass electromagnetic radiation into our sample, which actually consists of an atom or molecule, what will happen is this radiation will be either observed or emitted. Okay, that is the interaction that is happening between the electromagnetic radiation and matter. Okay, now when comes to spectroscopic definition, spectroscopy is the study of interaction between electromagnetic radiation with atom or molecule. So there are two chances, there are two principles that are possible to happen in that time. First one is absorption and second one is emission. Okay, the first one is absorption, which means when we pass light radiation into the sample, what will happen is the light radiation will be absorbed by the sample. So if that is called as absorption, and the spectroscopic instruments that are considered to have that kind of principle is called as absorption spectroscopy. For example, UV visible spectroscopy. And the second type is emission. Emission will happen when the light radiation falls on the sample. The samples will absorb the energy and it will go from ground state to excited state. Since the excited state is a non-stable one, and in excited state the electrons are considered to have more energy, the electrons will return back to the ground state by emitting some radiation at a longer wavelength when compared to the absorption wavelength, that is the excitation wavelength. The emitted wavelength will be at a longer one, and that principle is considered as emission because the electrons are actually emitting the radiations at longer wavelength. And the spectroscopic instruments that are considered to have this type of principle are called as emission spectroscopy. For example, fluorimetry. Okay, then we also have flame photometer, that will also fall under this category. And this spectroscopy can also be classified based on at what kind of sample the interaction is happening. For example, if the interaction is happening, the electromagnetic radiations are interacting only with the atoms, that kind of spectroscopy are called as atomic spectroscopy. For example, flame photometer and atomic absorption spectroscopy. In these kind of spectroscopic instruments, the interactions are happening only with the atoms, and they are called as atomic spectroscopy. And another type is molecular spectroscopy. So molecular spectroscopy, the interactions will be happening at molecular level. For example, UV spectroscopy, ultraviolet visible spectroscopy, and fluorescence spectroscopy, they are called as molecular spectroscopy because the interactions are happening at molecular level.